All right, guys, let's do 4.2. Good news, it's only one page, so they took it easy on us for the weekend. It says, write your name, period number, whatever it is, 1, 2, 3, 4, or 6, 7. Consider the pattern. So figure 1 almost looks like a field goal. Arrange the information from the diagrams into an input-output table. Something's going to go in, the machine's going to happen, out comes a number. Label the input column. I know that this is the input over here. That goes in the machine. And the output comes over here. So label the input column figure number, and that's going to be N for the variable. Label the output column number of squares, and that's going to be S. Label the center process. All right, well, that was easy enough. In the space to the right of the figures above, draw figure 4. So we're going to have to draw figure 4. How many squares are needed to build figure 4? Add this information to your input-output table. So figure 4, let's see. Let's see, if I have that middle one is there every time, so I'm going to draw that middle one. Now figure 3 has 3 here. Oh, no, I see. Okay, so you've got 3 to start with, 3 to start with, 3 to start with. Figure 1 has 1 on each side. Figure 2 has 2 here, 2 here, 2 here, 2 here. Figure 3 has 3 here, 3 here, 3 here. So I'm going to need my 3 center ones. Now, so I'm going to need 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. So I've got my 3 center ones, just like I do in all my other ones, except for just figure 3 has 3 here, 3 here, 3 here. Figure 4 has 1, 2, 3, 4, 3, 3, 4, 4. Okay, so we drew it. How many squares are needed to build figure 4? Well, we've got the 3 in the middle, and then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we've got 15. Add this to our table. So let's go ahead and make this an input-output table. Figure 1 has 1, 2, 3, 4, 5, 6 squares. Figure 2 has 1, 2, 3, 4, 5, 6, 7, 8, 9. Figure 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Figure 4, we just figured out, was 15. Okay, so if we had to figure out number 5, in the space to the right of the figures above, draw figure 5. How many squares? Okay, so let's draw our middle 3. There's our middle 3, and now we need 5. So there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 in figure 5. 18 squares. So if you notice, the output is going up by 3 each time. Okay, now in the space to the right, we did that. Now we've got to come up with the process. How do we get from 1 to 6, then 2 to 9, then 3 to 12, then 4 to 15? Well, I'm going to say that I'm going to take my input and multiply by, let's try 2 first. If I put this 4 in, 4 times 2 is 8, and I'd have to add what to get to 15? I'd have to add 7. So let's see if that works for this one. If I put a 5 in here, 5 times 2 is 10. 10 plus 7, no, is an 18. So that didn't work. So 2 didn't work. Let's try 3. Times it by 3. 4 times 3 is 12. I've had to add 3. Let's try it for this one and see if it works. Put a 5 in here. 5 times 3 is 15. Plus 3 is 18. So it works. So let's make sure it works for the rest of them. Put a 3 in. 3 times 3 is 9. Add 3, 9, 10, 11, 12. So that works. Okay, so we found the process. Process in words is to find the output, take the input, multiply it by 3, and then add 3. Okay, easy enough. Create a graph. Remember, the input variable is graphed on the bottom axis. So my input was figure. My input variable is figure number. Now I've got to go 1 through 5, so I'm just going to go, here's my y-axis, here's my x-axis, The figure number's down here in the input. That means number of squares is up here on my y-axis. So let's do, we've got 1 through 5, so let's just do every other one. This is 0, 0. So we've got 1, skip 1, 2, skip 1, 3, skip 1, 4, skip 1, 5, skip 1, 6, 7, skip 1, 8, skip 1, 9. And now I've got 6 through 18. Let's just go by ones then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I need to get to 17, or I need to get to 18. We're going to pretend like there's one more row here. I should have counted that first, huh? And then 18's at the very top. Should have counted that one. Okay. So now we got to graph these. If the figure number is 1, the number of squares is 6. So figure number is 1, number of squares is 6, connect them. And make a dot where they connect. So 1 and 6 connect right there. 2 and 9. So figure number 2 needs to match up with 9. So figure number 2 matches up with 9 right there. Figure number 3 matches up with 12 squares. So figure number 3 matches up with 12 right there. Figure 4 matches up with 15 squares. So 4 and 15. And finally, 5 matches up with 18, which we drew ourselves. All right, so if I connect these, that was terrible, sorry. I've got a positive slope. Okay. So, how many squares would be needed to build the 10th figure? Well, let's talk about our rule. We need a rule first. So, it's always output equals, so output is my S. So S, the number of squares, is always equal to the number of the figure times 3 plus 3. I just translated that into an algebraic rule. So how many squares, S is squares, would be needed to build the 10th figure? So N is my figure number, 10th figure. Bring down the 3, positive 3. PEMDAS says multiply first. 10 times 3 is 30, plus 3 is 33. So it would take 33 squares. Okay, let's see. Write an explanation of how you can calculate the number of squares needed if you know the figure number. Well, to find the number of squares, what do we do, guys? Take the figure number, and what do we do? Multiply it by 3 and then add 3. Awesome. Okay, write a algebraic rule that gives the number of squares needed to build any figure number. We already got that. The number of squares in that figure is always equal to the number of the figure, figure 1, figure 2, figure 3, times 3 plus 3. All right. What figure number has 60 squares in it? Well, let's start with our rule. What figure number? So we're looking for N. Bring everything's down. I'm looking for what figure number has 60 squares. Well, S is the number of squares, so let's put in 60. So I've got to figure out what number I can multiply by 3 and then add 3 to get to 60. Guess and check until you get it. I'm going to use my handy dandy calculator to help me. We get figure number 19. Let's double check ourselves. If I put figure 19, I should take the figure number, be able to multiply it by 3 and add 3 and get 60 squares. Let's try it. Figure number 19 times 3 is 57, plus 3 plus 3. Wait a minute. 19 times 3 equals 57. Plus 3 equals 57. Wait a minute. 19 times 3 equals 57. plus 3 equals 60. So we're right. Well, operator error there, sorry. Okay. Next, staying sharp. So let me help you with this because it's a little difficult. Let T represent the number of tables and C represent the number of chairs. Is the expression C times T meaningful? Well, let's figure out what C times T actually means. C is the number of chairs of each table. So number of chairs per table. That's C. When would I ever multiply that by T, which is the number of tables in the banquet hall? Why would I ever take the number of chairs that I can sit at one table and multiply it by the number of tables in the hall? Well, I like to put some numbers in it. So let's say there's 4 chairs per table, and we have 10 tables in the whole hall. 40 chairs per table times 10 tables gives me 40 what? 4 chairs per table times 10 tables, it's going to give you 40 total chairs in the room. So does it make sense? Yes. If you multiply C times T, it's going to give you the total chairs in the hall. Take a minute, pause it now, and really think about that, because this is where algebra gets a little bit hard. You have to write in letters and variables, but think in real life terms. So pause it here and give that a try. The rest of it is pretty, should be able to handle it. Only thing I'm going to tell you here is make sure that percent, you know that percent equals part over the whole times 100. And this question is asking for the part. All right, enjoy the rest of your weekend, guys. Bye-bye.